Okay, now it start recording. Okay, so kinematics of linear motion. Motion. This chapter is about motion. You know, talk about displacement, velocity, acceleration. Okay, so this is the linear motion. Linear motion means it move in a straight line. Okay, move in straight line. We haven't talked about rotational motion yet. So this is linear motion, move in straight line, moving left or right, up and down, yeah, forward, backward. Okay, so we have several terms we need to understand. Understand, yeah. For example, instantaneous velocity. Okay, there are students coming in yet, haven't added yet. So, okay, all right. So you need to know about instantaneous velocity. What is average velocity, uniform velocity? What are the difference between these three? Instantaneous and average velocity and uniform velocity. We also have instantaneous acceleration, average acceleration, and uniform acceleration. So what's the difference between them? Okay. Interpret the physical meaning of displacement time, velocity time, and acceleration time graph. So we have graph in this chapter also. Displacement graph, velocity graph, acceleration graph. Quite confusing, yeah, for some students. Yeah. So, okay, never mind, we will learn about it. And then determine the distance traveled, displacement, velocity, and acceleration from the graphs. So from displacement graph, velocity graph, acceleration graph, we want to find, let's say, displacement value, velocity value, and acceleration value from the graph. So how do we do that? So we will look one by one. Okay, this is the learning outcome that you need to achieve in this chapter. Yeah. Okay, so difference between distance and displacement. Okay, in short, is distance is scalar quantity. We have learned this in chapter 1. Displacement is vector quantity. Okay, distance is, what is it? Is the total path length traveled from one location to another. Yeah, it's always positive value. Unit is meter. Displacement is the shortest distance from initial position to the final position of an object. What does it mean? Shortest distance. It can have positive or negative value, whereas distance is always positive. Displacement can have positive or negative. And then unit is still meter. Okay, so let me explain this. Okay, so I like to use OneNote. Okay, so distance and displacement. So distance, for example, I show. Can you see? Can you look at my one? Boleh nampak tak OneNote saya?
Boleh, sir.
Boleh, okay. So this is the let's say this is the initial point. This is the final point. So we have two lines here. One is like this. One is direct. Another one is curving like that. Okay. So which one is distance? Which one is displacement? The blue line is distance or displacement, class?
Distance.
Yeah, distance. Look at here. Distance is total path length from one location to another. So distance is what we call the, you can make notes, class. Make notes. Is total path. Yeah, the total path. The longest path lah. Whereas displacement is the shortest path lah. Is the direct path, okay, or shortcut. Shortest distance, okay, the shortest path between initial and final point. Remember that. So distance means how far you have moved, okay, from initial to final point. So is the total path. But displacement doesn't look at what path you take. It just compare between initial point and final point. It just compare how far is final point from initial point. The shortest path is the displacement. Okay. So this one is displacement, and this one is the distance. Okay. So for example, class, I want to ask you one questions. Let's say I move from point A to point B 10 meter, and then I move to point C another 5 meter. Okay. So what is the distance I've moved, class? Total distance I've moved. What is the distance?
15 meter.
Which is 50 meter lah. Okay. But displacement? We just take the this is the initial point and final point. So between initial and final point, I need to do Pythagoras theorem lah. So displacement is 10 square plus 5 square. So what's the answer, class? I don't have calculator, or I have my handphone with me.
11.18.
Sorry?
11.18.
I can't hear.
11.118.
10 square plus 5 square, so cert is 11.18 meter. And then you need to say what direction, right? You need to say what angle, so you need to say the direction also. Because displacement is a vector, you need to say the direction. Okay? This one no direction. This one no direction. Distance is just the total path. Distance is just total path, no direction. But displacement, you need to include direction. You need to say, for example, this is the direction is theta degree below positive x-axis. Because why? Because we look from the initial point. This is the x-axis, so it is theta degree below the positive x-axis. Below. So this is the direction of the vector. The direction. Okay. Displacement. And the shortest path is 11.18 meter between initial point and final point. We say it is a shortcut lah. Shortcut. Okay, class? Understand?
Yes, sir.
Yes, sir.
Yeah, let's continue. So, a car traveled from A to B and then from B went back to C as shown. Determine the distance and displacement traveled by the car. So, how much is the distance, class? It moved from A to B and then B to C. What is the distance? The scalar quantity. What is the total path?
140 meters.
Yeah, 140. Okay, 140. This one I can. 140. I cannot comment. I can write anything. 140. Okay. But sorry lah. Okay, never mind. So 140. But displacement is 100 minus 40, isn't it? Which is, displacement is 60 meter to the right. 60 meter to the right. Okay, so that's this displacement and distance. Now, how about speed and velocity? Speed is distance traveled per unit time interval. Speed is distance traveled per time. Velocity is displacement over time. That's the difference lah. See, rate of change of displacement in a particular direction. This velocity has direction because it's a vector. Speed is a scalar quantity. Yeah, speed is a scalar quantity, no direction. Okay, velocity is a displacement over time. Displacement is a vector, so velocity also vector. So what I can say is, let me just write it over here. Okay, distance. Speed. Speed is total distance total distance over time taken. Okay, whereas velocity is total displacement over time taken. Okay, so because distance is distance is a scalar quantity, so speed also scalar quantity, has no direction, just speed. How fast is it? Yeah, sorry, no direction. Okay, but displacement is a vector, so velocity is also a vector. Understand, class? This one has direction lah. Velocity moving at certain direction. Okay, you need to mention about the direction. Okay, now further, so we can further elaborate. Speed is total distance, which means that we have learned that distance is total path, right? So to get speed, we take the total path over time. Total path over time, or the long path lah. Understand, class? The long path. But for velocity is total displacement over time. That means what is displacement again, class? Shortest path, shortcut. Do you write notes, class? You need to prepare a notebook beside you and write notes along with the video. Yeah, don't just watch only without taking any notes. This is just the same lecture class or tutorial class like any other class. Okay, so this hour is serious. Yeah, so this is the shortest path or shortcut over time taken lah. That's the difference between speed and velocity. Yeah, velocity we use the shortest path divide by time. This one we take the longest path divide by time. Okay, very important because in later when do questions, we always come back to this one. Come back to the definition of total distance over time and total displacement over time for speed and velocity. Okay, never mind, I will post this video again in the YouTube. Later you can watch again to get any notes. Okay, so the unit is meter per second. Now let's look at this example. Figure shows that distance AB and distance AC is equal, 50 meter, 50 meter. A car P takes 10 seconds to move from A to B, and another car Q take 10 seconds to move from A to C. Okay. The speed of both cars is the same because they have the same magnitude, but velocity of the car P is not the same as the velocity of car Q because the direction of motion is not the same. Determine the speed and velocity for both cars. Do they have the same speed, class? They have the same speed because both takes 10 seconds, 10 seconds, isn't it? Car P and car Q. Car P take 10 seconds, 50 meter. Car Q also 10 seconds, 50 meter. So 50 divided by 10. Yeah? 50 divided by 10. Let me take this thing out. Put it here. So you see this car P, go from here to here. This for P, and Q is here to here. Okay, P is to find the speed. Speed is distance is 50 meter divided by and then time taken is 10 seconds, so it's 5 meter per second. Okay, and then for Q, the speed is also the same lah, 50 meter divided by 10, so it's 5 meter per second also. But the thing is, they have the same speed. They have the same speed, but different velocity. Why, class? Why different velocity, class? Why different velocity? Because the direction is not the same. You see, P is moving to the right, Q is moving this direction. So because they have different velocity, because they have different direction. Okay, but they have same speed because they have same magnitude. Yeah, same speed, 5 5. Okay, that's all. All right. Now, coming to this one, instantaneous velocity and average velocity and uniform velocity. This is very important, this one. Okay. There is a difference between average and instantaneous velocity. Apa maksud dia? Okay, look at the average velocity. It is the rate of change of displacement over a finite interval of time. But instantaneous velocity is velocity at specified position or instant of time along the path of motion. Look at this graph. Inilah average velocity. Dia ada certain time period. But instantaneous velocity is just a certain point of time only, certain instant only. Understand? In short, I can write it like this. Yeah, I can write it this way. Apakah beza antara average velocity and instantaneous velocity? Apa beza dia, kelas? Maksud ini ialah this is velocity over a period of time. I suka guna bahasa saya lah. Over a period of time. Over a time interval. Tahu interval? Time interval ada satu julat masa. But instantaneous velocity is velocity at certain instant. At certain instant. At certain point of time. At certain point of time. Okay, maksudnya begini. Certain instance, certain period of time. Maksudnya begini. Normally we say this way. Average velocity between 1 second to 10 second. Apakah average velocity secara purata? Average velocity between 1 second to 10 second interval. 1 to 10 second interval. But instantaneous velocity is what? Instantaneous velocity at time equal to, let's say, 5 second. Pada satu masa tertentu saja. Ini satu julat masa. Ini ada satu julat. Ini pada satu titik. Satu titik atau satu point. Faham tak, kelas? Understand, class? Can I hear some reply?
Yes.
Okay. Because sorry, I cannot your message there. Okay, I can see your message already. Yeah. Alright. Satu titik. Okay, beginilah ya, begini. Let me explain in terms of graph. Saya bagi satu contoh graph untuk explain. Okay. Okay, orang ini let me see ya. Wait a second, let me see the okay, dia guna position time graph. Okay, good. Okay, let me use a graph to explain. Okay, let me use a graph to explain. Let's say a displacement time graph. I use a displacement time graph. Okay, begini. You tengok tak ini? Pernah belajar tak graf displacement graph? Graf sesaran, graf hal laju, graf pecutan. Pernah belajar?
Pernah.
Pernah kan?
Masa.
So, kamu faham tak? Ini adalah graf sesaran. Graph I need to use Malay because last time you use Malay, right? Some of you use English. Okay. Now, so this is a graph sesaran or displacement graph. Okay. Okay. Apa you boleh cerita tentang graf ini? Kereta ini sudah bergerak dari titik asalan, it move from the origin and then move up to, let's say, 10 meter. 10 meter. Okay. If from 0 second, from 0 meter move up to 10 meter. In let's say what I can give 10 second lah. I like to give easy number. Apa maksud kelas? Maksudnya kereta ini bergerak macam mana? This car, how is it move? It move from it move to the right. It move to the right. From if this in terms of displacement, it move from 0 meter to 10 meter. Okay, and then at 0 second, it start from origin, and then at 10 second, it reach 10 meter point. Okay. Okay. Ini ialah sesaran. Okay. So at 0 second, start from origin, and then at 10 second, it reach 10 meter to the right hand side of origin. Okay. So, but the thing is, graph dia curve ke atas kan? Betul tak kelas? Graph dia curve ke atas kan? Do you understand the curve yang graph curve ke atas? Kamu faham tak apa maksud graph curve ke atas? Do you understand?
Dia accelerate ke?
Accelerate, that's right. Dia semakin laju. You tahu tak? Masih ingat tak kecerunan? Apa maksud kecerunan graph, kelas? Apa maksud kecerunan graph untuk sesaran, graph sesaran? Velocity, hal laju. Betul tak? Nampak tak dia punya kecerunan semakin bertambah? Maksudnya semakin laju. Tahu tak? Beginilah. It start from 0 meter, and then after certain time it reach maybe 0.1 meter. But as time goes by kan, dia boleh bergerak semakin banyak jarak, boleh cover semakin banyak jarak. Bergerak ke 1 meter, suddenly become 3 meter, suddenly naik dengan laju kan, dia laju pergi kepada 7 meter, 10 meter like that. Understand? Dia memecut. Okay. So, what is the difference between average velocity and instantaneous velocity? This is what I want to explain. Look at this graph. When we want to talk about the kecerunan graph, kecerunan dalam bahasa Inggeris ialah gradient. You understand, class? Gradient is called kecerunan. So the gradient of displacement time graph is actually velocity. Velocity ialah ds dt. You belajar at maths kan, kelas? Ada tak belajar at maths?
Ada je.
ds dt ialah kecerunan graf. Masih ingat tak? Differentiation kan, kita cari kecerunan graf kan. So velocity is the gradient of the graph. Okay, velocity is the gradient of the graph. So that means like this one, you see this one, here has low velocity. Here has high velocity. Dia sini mula-mula, maksudnya kereta ini macam semakin laju tau. Mula-mula dia perlahan, tetapi semakin laju, semakin laju. Sampailah dia capai 10 meter di situ. Understand? Dia semakin laju. Dia punya velocity tu. Semakin laju. Okay. So, tengok balik. Apa itu average velocity? Apa itu instantaneous velocity? Itulah saya nak terangkan di sini. Average velocity and instantaneous velocity. I want to ask you, kalau kita tengok instantaneous velocity, adakah velocity pada setiap masa itu sama? Is it the velocity at different time the same? Or the velocity is increasing? Increasing, that's right. All of them have different instantaneous velocity. So if let's say I want to find the instantaneous velocity at 5 seconds, that means dia refer to velocity pada masa ini. Time at 5 seconds, velocity pada saat itu sahaja. Faham tak?
Yes, sir.
So this one, like this one, this is the instantaneous velocity. Dia ada bagi satu point masa, ya. Satu point masa at time equal to 5 second, velocity pada masa itu. Tetapi kita ada juga velocity pada macam mana nak tulis? Velocity pada 10 saat. Faham tak? Kita juga ada velocity pada 0 saat. Dan kita boleh kata velocity pada 10 saat lebih besar daripada velocity pada 5 saat. Lebih besar daripada velocity pada 0 saat. Understand not?
Understand, sir?
This is what we call the instantaneous velocity lah. Yeah? Instantaneous velocity at certain time. Susah nak tulis ini. Instantaneous velocity. Okay. So they have different velocity because dia objek semakin memecut, semakin laju. So velocity pada 10 saat paling laju lah berbanding dengan yang 0 saat. I think 0 saat dia garis melintang kan. Kalau melintang means zero velocity. 0 meter per second. It means start from stationary. Objek pegun. Awal-awal objek pegun. Then dia mula bergerak. Mula-mula objek pegun or stationary object, then it start moving. Okay. So initially velocity is 0 and then it start to accelerate and then become high velocity in the end. So this is instantaneous velocity. They can have different velocity depending on gradient of graph. Okay, depend on gradient of graph. If the gradient changes, instantaneous velocity also changes. Understand? But what is average velocity? Average velocity means purata. Velocity purata pada satu julat masa. Maksudnya, saya ambil average velocity cuma ada satu nilai sahaja. Maksud saya begini. Yang instantaneous velocity boleh banyak nilai. Ya? Or depend on the gradient of graph at any point. At any point, at any time. But average velocity only satu nilai saja. Sebab dia ambil purata, nilai purata di antara masa ini. So this is it looks at gradient of whole graph. Gradient of whole graph of that time interval. gradient of whole graph of that time interval. Maksudnya macam mana? Satu nilai. Macam mana cari average velocity ni? Let's say I want to find average velocity from 1 second to 10 second. Okay lah, make it simple. From 0 second to 10 second. I take the whole time lah. Saya boleh ambil julat lah. Saya nak ambil julat dari mana ke mana kan. Kalau saya nak ambil keseluruhan graf, saya ambil 0 to 10 second. Okay, so macam mana nak cari average velocity? Senang saja. Ambil point ini, sebab saya start dari 0 second kan. From 0 second up to 10 second. Saya buat satu garis lurus ke sana. Ambillah kecurunan triangle ini. Ambillah kecurunan ini. Okay, understand lah? So, this kecurunan graph ini, okay, we can say how to find the average velocity. Average velocity is total. Again, what's the definition of average velocity? What's the definition of velocity? Total displacement, isn't it? Velocity is total displacement over total time. So, total displacement. Average velocity is total displacement over the time taken. So, what is the total displacement from 0 up to 10? 10 meter lah. Understand? 10 minus 0. Understand or not? 10 tolak 0. 10 lah. Bahagi dengan masanya berapa? How much time taken? 0 to 10 second? 10 second lah, isn't it?
10 seconds, sir.
So, berapa dia? 10 bagi 10. 1 meter per second. Satu nilai sahaja. Untuk inilah nilai purata untuk julat masa itu, untuk time interval itu. Satu nilai sahaja. Tetapi kalau kita tengok instantaneous velocity, dia banyak nilai. Sebab dia punya kelajuan semakin bertambah. Kelajuan dia berubah kan. The velocity is increasing, changing. So they can have different instantaneous velocity at different time. Understand? Banyak nilai. Ini average velocity satu nilai saja. Tengoklah, kalau you nak average velocity untuk keseluruhan masa, kita boleh juga ambil dari kita boleh juga cari average velocity from, let's say I just want this time interval from 2 second to maybe 7 second. Then saya ambil displacement pada julat ini sajalah. Maksudnya di mana? Saya lukis semula lah. Lukis semula kah? Tak apalah. Saya rasa 2 second up to 7 second. Where is the 7 second? Maybe over here kan. Saya ambil triangle inilah. Triangle ini. Carilah dia punya gradient di sini. Faham tak? Faham tak kelas? Faham ah? Ya betul. Justin, abang Justin ke yang Justin? Okay. Okay, so itulah dia ya. 2 to 7 second. Nanti kita ada soalan ya. Kita ada soalan lebih faham lagi ya. Saya sini nak terangkan konsep lah. I just want to explain the concept ya. Okay. Okay, so itulah dia, senang sahaja. You see that? Average velocity take the whole time, ya. Yang 12 tolak mana? If you look at carefully here, it is 12 minus 2. Divide by what? Maybe what's the time taken? 12. Oh, this is around 12 minus 2. I think you get 9.4. And then he what time between 2 point? Time taken is between here up to here. So the time is around 4.3 second. Ya. Kenapa tak selari? Okay, tak apalah ya. So he ambil 9.4 divide by 4.3. You get 2.04 second. Meter per second. That's average velocity. But kalau instantaneous velocity, velocity at certain time. Maybe velocity at this time only, at this time. So ya ambil gradient untuk point itu sajalah. Gradient untuk point. Kita sendiri yang buat garis yang panjang. Ini garis yang kita buat sendiri. Sebab kita nak ambil gradient untuk point itu sahaja. Ya, dan kita besarkan triangle itu supaya kita senang nak cari gradient point itu. Dapat instantaneous velocity 3.25. You see, average velocity dengan instantaneous velocity dia punya nilai lain. 2 ini 3 ya. Sebab lain, maksud dia lain. Ini velocity at certain time. This velocity at time interval. Okay, at whole time. Okay lah, itu saja. I think sampai sini saja hari ini ya. Saya nak you tahu average velocity is velocity over a period of time, over a time interval. But instantaneous velocity is velocity at certain time. Certain instant means certain time lah. Certain instant means certain time. Okay. Until here. Later we have average acceleration and instantaneous acceleration. Same thing is the same. This is also acceleration at certain time interval. This one. Instantaneous acceleration is acceleration at certain time, at certain instant. Sama maksud macam yang velocity. Tapi kita akan balik ke sini hari lain lah. Ya, dan kita akan bincang soalan lagi. Dan kita akan bincang graf. Okay? I think sampai sini saja dulu. Sebab kita kira dah selesai satu konsep yang penting hari ini. Which is what's the difference between average velocity and instantaneous velocity? Uniform velocity means velocity is constant. That's it. Yeah, velocity is always constant, not changing. Itu saja. Okay, tak ada. Yang penting antara average dan instantaneous velocity, apa beza dia yang penting ya. Okay, itu saja. Okay, so itu saja. So see you in next class ya. Thank you everyone.
Thank you, sir.
Okay.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir.
Welcome.
Thank you, sir.
Thank you, sir.
Yeah.
Thank you, sir.